Hello world. Today we're going to talk about a C++ specific design pattern that you probably already utilize but may never have heard of called type erasure. The motivation behind type erasure is to allow us to bind multiple unrelated types behind a single non-templated class. Let's consider this example where we have two structures, Link and Zelda, that are themselves unrelated in that they do not inherit from a common base class or each other. If we wanted to take advantage of the commonality between these two classes, this print name function, then there's a couple of options that we would have. The traditional way that we might handle this is to inject a common base class between the two to relate them to each other, and have that common base class declare this print name function virtual so that we can get some polymorphic runtime dispatch from one to the other. But there is another way. I know I'm going to want a class, I'll call it here type erased, that is itself untemplated, that is constructible from or assignable to a Link or a Zelda, and is then going to have that interface that is shared between the two or common between the two exposed through it. Based on the usage I've laid out for myself here, I know that I'm going to want my type erased object to construct from and assign to either a Link or a Zelda, so I'm just going to template those. And then I also want my type erased object to have that same common interface from between the two, in this instance, print name. The next thing I want to think about is how I'm going to hold on to this value that I'm given either through my constructor or assignment operator, particularly when the two types are unrelated. So I'm going to have to put a relation back to those in some way so that I can hold on to either. What I'm missing and thus need between these two classes is this relationship between distinct types through a common base class. So I'm setting up that relationship here, and then I'm going to make this derived class actually hold on to a value which I know is going to ultimately be one of my other distinct types. My type erased object is going to hold on to a unique pointer to concept. Concept is going to be the base class for all these specializations of model. Model's responsibility is to know the actual type that it holds. Now, based on the actual type that I'm holding, I've updated my constructor and assignment operators to be appropriate for this type. That is the unique pointer of concept. Here I'm going to have my constructor forward on to my assignment operator, and my assignment operator is going to be defined to reset the unique pointer to a new instance of the model for that type, giving it the value object. Now, if I have successfully typed everything, I should see that this compiles, though it shouldn't be functional yet. It appears that I've been caught by the most vexing parse problem. So let's take a look at what I did wrong here, because it's a quick learning moment. So what I need to do here is change this line to be clear that I'm trying to initialize an object. Ta-da! If I run it, as expected, see no output, although it looks like it didn't crash either. So you know, progress. Next, I need to implement my print name function on type erased. It's going to forward on to a function of the same name on concept. Concept is going to declare its print name function as virtual, and pure virtual, in fact, because it will have no implementation of it itself. And that forces model to implement it. In this case, I can make sure that I'm actually overriding what the concept has declared, and it is going to then forward on to its values print name. In that instance, either a Link or a Zelda. Again, if I got this all set up correctly, we should see it build and run. There you have it. First, we are constructing a type erased object, TE, from an object of type Link. So it's going to go through our constructor here, which is going to forward on to the assignment operator. The assignment operator is going to reset our unique pointer to a new instance of model of Link that has been deduced through here, and pass it this value of Link. That model is going to then store that value of Link internally as that exact type. When we go to print name, we have our model of Link held as a concept pointer. So that print name function is going to go through the virtual dispatch to the model of link's print name, which we'll call to link print name. Likewise, our type erased object will get an instance of Zelda through its assignment operator. It will reset the unique pointer of concept, which was a link object prior. So that link object will be torn down through that virtual destructor from concept so that the model of link can actually destroy the link object appropriately. The new model of Zelda type will be initialized with that value, Zelda, that we gave it, which again will make a copy of it into model of Zelda. And then when we do print name, just like we saw for link, we'll dispatch this time through the concept pointer to the model of Zelda. So we'll get the model of Zelda's print name called, which will dispatch to Zelda's print name. And that is how that works. Some of the points to commit to memory here are that the type erase class is itself not templated. It is going to have a templated constructor. It is going to have this concept class that the type erased object will hold a pointer to. And it has a templated model class that inherits from concept, whose responsibility is to know the actual type that the type erased object is ultimately going to be holding, so the type erased object can forward on to the underlying value through this construct. One of the unfortunate parts of type erasure is that it requires you to reproduce the interface 1, 2, 3 times. It is a bit trivial, but it is also fairly tedious to do. The customary example for type erasure is the class called any. C++17 adds this class any to the library, and the idea of any is it can just hold any type of object and make sure that it gets cleaned up correctly when it's done. But there are actually a few other areas within the library that type erasure appears again. Stood function is another type erased object within the standard library, although this one looks a little bit funnier because it actually is templated, but the template parameter is the signature of the function that is going to be exposed on the stood function. Here, our stood function returning void and taking no parameters can be assigned to just an empty lambda, or we can give it an instance of a class that has the parens operator defined on it, or we can just give it a function pointer itself. And all three of those completely distinct types are going to be storable within stood function and then callable through it. One more instance of type erasure in the standard library that's a little less obvious is what's going on underneath the hood with shared pointer. Shared pointer has a feature that shared pointer to a base class and a shared pointer to a derived class can interoperate with each other. The way that shared pointer works under the hood is one of two ways. If you use make shared, it's going to allocate a chunk of memory for both the reference count and for the object that it's storing. If you allocate the object and hand it into the shared pointer, then it's going to allocate a chunk of memory for the reference count plus a pointer to the object that you gave it. In both of these cases, a shared pointer to a derived class can share that reference counted object with a shared pointer to a base class. So long as these two types are related in some way, they can internally share that structure underneath. That means the shared pointer object has to use a form of type erasure underneath in order to handle either of those types of objects, or to potentially, if it is a shared pointer to a base class, to have a pointer to a derived class. So it's a little bit less obvious, but it is another instance where type erasure comes in to save the day. Thanks for watching. I hope you enjoyed the video. If anything was unclear or you would like to hear about another topic in the future, please let me know in the comments. And don't forget to subscribe if you'd like to hear more.